Is that done? Yes, I think we're recording now. So, yeah, you're all very welcome to the Dublin Data Science Workshop. Like I said, I'm recording this, and this is going to go up on YouTube. I've essentially created a playlist on the Dublin Data Science channel on YouTube. The previous two workshops have been up there. They're about 2 hours long each because that's the length of the workshop. And it just came from people asking about it and if they could record it. And since we went online, I thought, why not? You know, I'd ran some workshops online, and while we still have the materials, sometimes it's not, people just like having it on a video. So I thought, yeah, sure, I'm okay with that. I probably should have shaved because it's been a while, but never mind. But yeah, so we're talking today about the retail data. So it's got a continuation from the previous two. Just to quickly ask in chat, how many here have been at previous ones of the workshop? Would you mind just popping yes or no into the previous chat, into the chat message, just so I get a sense of who has been here before and who has not? Because we do tend to, with these workshops, because they're done as a series, we do tend to have, you know, a mix of people who were either at the first one and have came back or missed it and whatever. So, okay, excellent. So I've got a bunch of yeses. Is there any no's at all? If there's any no's, just now's your time. I've been at a Bayes workshop. Oh, Bayes. Oh, okay. All right. In Ireland or online? EC, that is. Oh, brilliant. Okay, excellent. All right. Okay. Very good. Yeah. I've heard that there's these legendary things called pubs, but I'm not entirely sure. I'm pretty sure it was psychological torture that someone invented. Because, you know, my mind doesn't remember the outside times.
Pubs? We've got pubs over here. Mate.
So I heard about them. Yeah, your guys
open.
Yeah.
Yeah.
No, they haven't opened here.
Yeah.
I wouldn't.
Yeah, only outside.
I wouldn't like to be a publican at all. It's been it's been pretty harsh. But anyway,
on the 17th we can go in them, I think.
Oh, really?
Yeah, mate.
It's a very different regime here.
Yeah.
Great. Okay, so EC. Well, if you haven't been at any of these, you do kind of get a sense of the format anyway. So basically, what I'm going to do today is I'm going to go over the data for just a quick kind of summary. The first 15-20 minutes of the is going to be a quick summary of the previous workshops, trying to just get a sense of where we were and what we've done, just to get everyone up to speed. And then we'll continue on. I'll try and take a break sometime around 8 o'clock, but just it depends on the flow and the questions and stuff. It might be 7:45, it might be 8 o'clock, it might be 8:05, just depending on kind of just how things go. I usually try and get a very natural kind of logical stopping point, and then we'll take not very long, maybe 5-10 minutes, let people go to the bathroom, grab a cup of tea or whatever, just to kind of break things up a bit. And also at that point, what I'll probably do is, if there's any kind of longer form questions that need discussion, we can kind of address them then we'll go back into it about, you know, depending on when we stop, leading it through. And then I'll probably try and wrap up around 8:45. We might go longer, but usually I try and finish a little bit earlier, just, you know, give people the rest of the evening. But I'm always happy to stay on, you know, take questions if anyone has any comments or, you know, things they want me to explain better or whatever. You know, I usually stay on at least until 9 and usually till 9:15, just chatting and discussing stuff and whatever. And I'm more than happy to do that. That doesn't bother me at all. We'll often stop the recording though, so especially if, you know, people can ask kind of more franker questions or whatever without the, you know, the things being recorded. Also, I can give probably a bit more honest answers as well. Sometimes I have to be a little bit more politically correct, or at least discreet when you're when you know you're going on YouTube. So basically, the idea of this, as I said, it's data science soup to nuts, and it comes from an old English expression from soup to nuts, which was when, you know, a full evening meal was, for the upper class, was you started with the soup, and, you know, you would have your 5 or 6 courses, and you would end with nuts and cheese. So the idea from soup to nuts is from start to finish. It's kind of a fancier way of saying that. And the whole idea of this is, and it's a topic that kind of a few of my colleagues have discussed, and it's kind of a common refrain, is that you can learn all of this, data science and stats and machine learning and all these kind of fancy things, but when the rubber hits the road and you actually have to apply them in real world, a lot of people kind of freeze and they aren't exactly sure what to do. And part of that is kind of a function of the educational system, because, by definition, for them to focus on things, they're trying to teach the algorithms and they're trying to teach the approaches. So typically all the messy stuff involving getting data and data cleaning and what the problem is and all that, you kind of have that solved for you. And it's kind of part of the setup of the problem. And then so you have your data set and it's all ready, and then you run your clustering, whatever, and you discuss the different clustering approaches and how you describe the clustering outputs and all that kind of stuff. But that initial part of getting the data and figuring out what the hell you're going to do with it and how you're going to clean it, and are there any problems, and what about missing data and all those kind of things, they typically haven't been covered well, and I got a lot of questions about it. So I had this idea ages ago to have this kind of a series of workshops whereby, we start taking just a data set from raw, we do a whole bunch of data exploration, data visualization, figure out some models, run some models on it, and then, do the exploration, do the visualization and communication of results. So the idea is that would be that. I kind of knew in my head, I had like 3. I kind of knew in my head there was no way I was going to cover most of the topics in 3. And at this point, it's online and I've got nothing else better to do. So I'm just going to do it for as long as it seems natural. I'm not going to try and compress it or force it. So I expect maybe it's going to be, this is the 3rd one. We're starting to do some data modeling and stuff. The modeling and all that won't take actually long, to be honest. I'm not going to spend a lot of time on that, because typically you don't spend a lot of time on that in the model. And instead, I'm going to run some models, figure out which the best one is, and then do some visualization and communication. So probably it'll go 5 or 6, depending on how things go. And maybe one thing already, I have a new idea for a series based off one model here that I probably won't have time to cover in as much depth as I would like, because it's interesting. So yeah, so the data set is a retail data set that came from the UCI machine learning repository. So it's up. I may as well just share the link for those of you who haven't been here before. There's an online retail 2. Retail 2. Now, this is going to be, for those of you who are used to my workshops, and I think most of you, I don't think anyone else actually said no. This is by design going to be a bit more, this particular workshop is going to be a bit more messier, and I don't want to say chaotic, but it's not going to be as neat, which I know is a very low standard anyway, as previous ones. And I kind of did that deliberately because I kind of want to convey the idea of, when you're presenting your results and stuff, it all seems like a fait accompli, and it's presented in a kind of neat bow, and it kind of has to be, if you're going to convey whatever story or whatever modeling idea or whatever it is that you want to convey, it kind of needs to be neat. But the actual process of it, it's a bit like the swan, it's all graceful above the surface and it's pedaling like crazy below. A lot of data sciences are like that. So what I'm trying to capture today is just basically the messiness of modeling and trying to figure out what you're going to do and how you're going to present it. Because it's very, very rare that someone will say to you, here's some data, here's exactly what I want to learn out of it, here's the techniques you need to get me those answers, and off you go and come back to me when you've got it all done. In reality, it's something as vague as, how many customers do we have, or who's our most valuable ones, or can you tell me a way of keeping or what's our customer retention like? Because in many cases, you have all the databases and the data to tell you it, but some of the kind of higher level questions are not as easy to answer. And even a question as simple as, how many customers do we have right now, is not simple, because if you're an online store, it's a transactional system. So it's not like you have a contract with them. So you don't really know, is a customer who's came, have they left and they're never coming back, or are they going to come again? Or, and how do we answer those questions? So, trying to get that and figuring out the ways to do it. And that's what I'm going to try to capture today, once we've kind of set it all up. So there's the online machine learning. And just to give you, this is where I got the data from. So I pulled it down. There unfortunately isn't a whole lot. And you can see here, there's 8 fields. A country, customer ID, unit price, invoice date, quantity, some free text description of the stock code, and then an invoice number. So there's not a huge amount of data in here. There's about a million rows. As we discussed in some previous ones, there is a certain amount of overlap. There was a duplication. The data came in an Excel spreadsheet that had 2 tabs, and essentially there's a certain amount of data overlap between tab 1 and tab 2. as I discussed in a previous one, I didn't actually realize there was two tabs because I never opened it in Excel. And that was a stupid mistake of and doing as I do, not what I say, listening to my own advice. I didn't actually realize it until I noticed there was only 500,000 rows. And when I checked it against this, I thought, oh, wait, that doesn't sound right. And that was when I opened it Excel, I immediately saw the problem. So the lesson to learn from that is even if you're not using Excel, if you can at all, it's always worth opening a data file in its native environment, because you can get these silent translation issues that will be completely invisible to me to yourself if you don't know any better. So we have these 8. It's a very simple set of data. It's basically got, like I said, it's just the customer ID, how much of the unit of the particular unit was bought, of the particular stock code, what date it was on, what price was paid, and the customer ID, and that's it. Like there's nothing else in there. So the question then was, well, what do we do with this? Well, we did some basic data cleaning, did some plotting of the data, figured out some issues. Is there what's in there? Some of these are returned. As it turned out from looking at the data, it became very apparent that there's a whole load of stuff in here, including things like the cost of postage and Amazon returns and various fees for gift cards. There's a whole load of extra stuff in here that wasn't necessarily documented, but the process of data exploration kind of threw a lot of that out, and that's what we kind of discussed and got through all the various plotting of it. Produced a whole load of plots. I have kind of my own little template R Markdown workbook. I should mention, all of this is done in R, but I'm trying to make this as generic as possible in terms of how I discuss, because I use R personally, but for people who want to do this stuff in Python, most of this will be very, very doable in Python, certainly up to, at this point now, using pandas and plotting functions. You could probably use Julia as well, although I'm not as familiar with Julia as I used to be. Yes, hat tip to Malcolm there. But generically, any kind of data manipulation language, usually R and Python, could be done. I'm not quite sure how it works once you start going into the more statistical techniques. I think buy till you die, for example, it has been implemented in Python. I'm not quite sure. I know there is some customer lifetime value things like lifelines and stuff like that. That's in Python. I can't talk about actually the model fitting things like the Peter Fader stuff that we're going to talk about. The graph stuff definitely would be in Python, but again, that would be more on the graph data rather than any like graphical modeling that we might get to. I haven't decided yet if it's relevant or not. Probably won't be, so that's going to be okay. And then the third one is time series analysis, which is apparently has been done quite well in Python, but I don't really know too much about it. But if by all means, if there's stuff that we talk about when I do it in R, I'll probably do a shout out for any Python programmers here. And if you find out that there's there's libraries that can be done, please let me know, and I'll happily give people a shout out to point them that way, because I'm conscious an awful lot of people use Python these days. I just prefer R because my approach tends to be more applied statistics, which is just better represented in R. Okay, so yeah, we did all that. We did a bunch of stuff. The other thing I do want to give a quick shout out for is another package that I kind of found out about after I kind of into developing this. And at some point, I'm probably going to change mine to use Data Explorer. There's a package called Data Explorer in R, which is absolutely brilliant and is way better than my stuff. But it has all the kind of the stuff that my template does, like plotting, plotting missing data, how many different types of columns there are. I wanted to plot some of that stuff out there. So I used it here where I did some cleaning and I found some extra columns and stuff and filtered out like the returns and all that. And then I plotted the cleaned data using Data Explorer. So if for any who are interested in this kind of stuff and want to look at it, there is a whole lot of really good stuff in Data Explorer that I would more than happy to recommend, massively more so than my one. Ideally, what I would like to do, because my template kind of goes through my workflow, it would probably be better if I can incorporate a bunch of the logic in Data Explorer to create, my one. So we did all that. We looked for missing data. We figured out there was a whole load of returns. You can see here, like plotting just the prices on individuals. We get these mad amounts. Makes us want to look at, what causes it. Essentially, it led us to find out that, there's a whole bunch of weird stuff in here that we didn't really know. So I'm looking at things like the different stock codes, items per transactions. Actually, off the recommendation of Patrick, who's in the audience tonight, a good idea was, from checking the data, was we have a stock code and a description. Check to see that if you have a stock code and a description where the description and the stock code are different, check to see, just in case someone's recycling stock codes. So in other words, stock codes aren't necessarily distinct and unique to a particular item of stock. Thankfully, in this data, that doesn't seem to be an issue. There are a few discrepancies between the description and the stock code, but it's usually just something reworded or missing, rather than the item is a completely different item. So at least in this data set, we don't have to worry too much about like stock codes being reused. I imagine that would be something that's much more of an issue though in the event of like legacy systems where you've got data going back longer and you had limits to how many data values you could have, and or stock code, or stock code 9999 for free text. Yeah, that kind of stuff. Just trying to figure out if those are in there. And that's, like I said, I can't emphasize the importance of data exploration and data visualization enough. And that was why basically we're 3 workshops in and all we really got to was working on data exploration. And today we are going to start moving into the modeling aspect of it. But to be honest, it's still really from an exploratory point of view rather than building a predictive model. I haven't really thought about that yet because I'm not really sure what the best way to do it is. And at some point, I'm probably just going to have to make a call and arbitrarily decide what the point of this project is, because I didn't really have one going in because I just didn't know what the data would do. And I'm learning a lot of models here. So I just I'm going to pick some questions that can be best answered by the data, or at least a handle on it. And then, go from there. So we kind of looked at item counts per transactions. So, how many different distinct items are in a basket. If we count an invoice ID as a particular basket, the data set itself, you can see here, there's some numbers, and we can we can look at a few more here. Let me look at 50. So you can see groovy cactus inflatable, bendy color pencils. This was some kind of Etsy website style thing by the looks of things that was in operation at least from 2009 to 2011, because that's the time frame this data covers. So you can see here like coloring, brown pencils and stuff like that. But then there's these weird things here like wet, rusty and damaged. So these are probably like returns where the description is why it was returned, but also like zebra invoicing error. So you just get weird stuff in here. So some of the things I had to do was, build some time series data, see if there's anything weird, but like checking the distribution of the daily purchases. So we kind of looked at all these the last time. Like I said, I won't go into too much detail because I'm conscious I don't want to eat up too much time. And then one of the things I have done in the last kind of while was investigating refunds. So one of the things I didn't completely ignore was refunds and just look at the purchases, because if we're trying to figure out customers, an important looking at customer was to make sure that you don't have customers who buy a lot of stuff and then return a lot of stuff, because you don't end up making much money off them. And in fact, you could end up being negative cost, because if the cost of the returns is very high, and I believe that is a problem that some of the big retailers like Amazon and Zalando and stuff have discussed with me, is that I've talked to some of the people that like returns can be very expensive. So in certain cases, like it's fine for a first approach, but for a proper model that's actually going to influence business decisions, it's important to kind of account for that and possibly build in the cost of returning and the cost of shipping into your models. Because that way, you could have a customer that looks amazing on paper because they buy a lot of stuff, but then they return it all and you end up you actually lose a lot of money on it, because the net amount they purchase is massively overwhelmed by the cost of shipping the goods to and back from them. Unfortunately, the data doesn't really lend itself well to this kind of thing. So when they create a return, they don't link the data back to the original purchase. It just has a separate invoice ID. Cancellations have a C at the end of them, I believe, but it's just the item type and a price. So I kind of went through this whole exercise of creating data to basically look at previous transactions when you see a return, and essentially look at the previous transactions where the same customer bought the same item at the same price, and then essentially create like an adjustment so that, you know, and work backwards. A very simple way of doing it is just canceling, doing an offset, matching the most recent one. But then you also have the issue as well, maybe they returned, you know, if they bought over 3 days, they bought 3 amounts and then they returned it all at once. So accounting for those edge cases. What I've done with that so far, I kind of went down a rabbit hole and I realized I had gone down a rabbit hole trying to solve this problem. So what I did was I got it to a certain point and then I've left it. And I'm going to ignore that aspect for what we're talking about today. But I think in the next workshop, I'm going to bring that stuff back in and start looking at net amounts or maybe modeling probability of return. I mean, like I said, there's loads of different ways we can go about this. And I haven't quite decided, and it's not insignificant either. So, and it needs to be thought about. And you can see, yeah, I just went the days between the purchase. You know, in some cases they were cancelled almost immediately, but in other times there was a long distance between them. And then we had all these weird stock codes like B and C2, C3. So I kind of did some analysis of it. I just opened it up in Data Viewer, I think, and I looked at the weird values that were in there. So where the stock codes were less than, so most stock codes here had like 4 or 5 alphanumerics and possibly some letters in them. So where those kind of patterns were violated, I looked at the stock codes and it threw up all these. And they just kind of, I wasn't quite sure what all of them were. I mean, some of them were like postage. I can't remember what DOT stood. There was bank charges in there as well, where the company literally, like, you know, it looks like they were charged by a bank charge. And for some reason, it got into this transactional data set. And Amazon fees for delivering stuff. Presumably, they had some kind of system where they sold their stuff through Amazon and Amazon charged them a fee. That got put in here and it was registered under a stock code. So I looked at all them and I kind of cleaned all them out. And essentially what I did was I created an exclusion indicator. So essentially I took the data and you can see I'd added all these extra columns in here, like invoice hours. I broke down the various timestamps. I looked at the stock codes, and what I'm doing here is basically saying if the stock code matches any of these kind of flagged ones here, just flag them for exclusion. So rather than removing them from the data set, because I wasn't quite sure, like I said, going back with returns and stuff, there's a few different things to look at. I instead created this exclude flag. So if it was like a return value, or if it's got these weird code numbers or whatever, I just exclude it. And then in subsequent analysis, I can just filter all those rows out that have a true value. Yeah, exactly. Sorry, just seeing here in chat. When conscious of a rabbit hole, label it to do and move on. That's the, I'd spent like a couple of hours on this and it became an interesting, the problem with it was an interesting engineering problem because, you know, I started thinking about the moment I realized that I had gone too far was when I had this genius moment. I think I was heading to the bathroom or washing my hands or making a cup of tea or something. And, you know, your brain kind of figures out in the background. And I went, I know, this is a stack. And what I need to do is for every customer and item, I need to create a stack. And when they sell stuff, I add it, I pop it, I push it onto the stack. And then if a return, it gets popped back off. And that would be brilliant. And that way I can keep track of it all. And it was at that point that I realized that I had gone way too far down the rabbit hole and that this wasn't, while it's good to do this, the perfect is the enemy of the good here. And at some point I just need to do some fucking modeling, if you'll pardon my language. Oh, I'm probably going to swear today. I should flag this in advance. This is going to get flagged in YouTube as well, because I'm modeling about stuff. And when I model and get confused about stuff, sometimes I swear. So when relating kind of the how this all came about, some swear words. So if that offends you, my apologies. But I may as well just flag it in advance. Okay, so yeah, so once I realized I went into engineering mode of solving this thing through stacks, that was the point at which I went, yeah, you probably just need to stop and move on because, you know, come on. As they say in Derry Girls, catch yourself on. So yeah, so I kind of just said, okay, leave it. You know, this stuff will take care of itself. We'll come back to it. We're just, so for the purposes of what I'm doing today, but I possibly could, but that might be possibly. Patrick, possibly I could edit it, but we'll see. That might be a fair bit of editing depending on how today goes. Although there's probably automatic bleeping now at this point, knowing YouTube. It's kind of crazy, the video processing they have. Anyway, right, so despite what I said about returns being really important, because of the rabbit hole I went down, and it was one of them that if I'm going to solve it, you kind of need to solve it properly. Otherwise, you've put in a whole load of effort to not really solve the problem. I've kind of ignored it for today. So for the purposes of today, I'm just going to exclude returns from the data set along with all the others. So basically where this exclude equals true is being filtered out. So we're only keeping ones where exclude equals false, and we're kind of moving on. And then, like I said, so we have this one with the missing, and this is basically one of the things I found a use for Data Explorer here. This is basically the Data Explorer analysis of the cleaned data set where I've excluded all the true values. And that's kind of, you can see that there. And that's what I'm using for the rest of this. Now, I haven't done much in there. This is kind of going to be the worksheet that I use to learn how to use Data Explorer properly. Okay, so we have a data set. We know there's some problems with it, but for the most part, we've gotten rid of the most of the really problem. Oh, the other thing I looked at was there was a couple of transactions amounts where like an invoice was a huge amount of money, like 50 grand or something like that. And that was how I found out about Amazon fees, because some of the really, really large numbers, and that was why if we go up here and look at the custom explorations, you can see the transaction amount just had a stupid range on them. Hold on, let me just move up here. There was very large numbers. Yeah, you can see that's the price and the negative values, and it's here somewhere in the stock value. Yeah, you can see we just get stupid numbers, even when we do the positive and negative. Looking at those really extreme values, I flagged that there was like expenses in here, like I think it was like bank charges and Post and Amazon or whatever, and it looks like they just lumped them all in there. So that was the other reason, because it meant you kind of filtered down. There was also some silly ones where there was a fat finger, where someone bought a crap ton of stuff and probably put in one too many zeros. The purchase went through and they immediately reversed it. So those kind of things. So that's the other reason why exclusions are like, and returns are important, because otherwise you just get these very skewed numbers. But anyway, like I said, we're kind of exploring that. We're ignoring that for now. So, and that got me, actually, I did that quicker than I usually do. That only took about half an hour. So what we're going to look at today is, so the question we have is, so we have now a data set. Looking at the excluded values, let me just check. I think there's still about 1 million rows in it. If I look here, hold on. So yeah, so even when we exclude the returns and things like bank fees and all that, there are still just over 1 million rows. Right now we have all the columns that we have. So we've still got a fairly chunky data set. Now, again, these are single line items. So like if a single purchase had 10 distinct items in it, there's 10 rows in the data set. In terms of the number of invoices, actually I'll live code because, you know, that's how I roll. Actually, let me just run that one. Exploring retail, and that way I'll actually have the data. Nope, I will initial rules models. That's because that's the one we're going to be working on first. I'm just going to render the code. I think there's about 50,000 invoices. So there's about 50,000 transactions, let's call them, where someone actually bought stuff. And then within that transaction, you have all these different items. So one of the things that's a very obvious thing to look at for me when you're dealing with transactional level data is what's called basket analysis. So essentially what you're looking at is, you know, given that you've bought some things, what items tend to be bought together? So this goes back to the classic kind of association rules thing, which is kind of one of the things that when people started talking about data science, it's the whole beer and diapers thing, which apparently is apocryphal. But it was based on the idea that when people started looking at things that got bought together, they weren't immediately obvious things that were associated. But then kind of once you thought about the second order effect, it made sense. And the kind of the canonical example is the beer and nappies, to use the English term or the Irish term rather than American. So the idea was that they found when people started buying nappies, they also started buying beer. And that, you know, it's not something you'd necessarily associate, but it makes sense after the fact when you realize, oh, of course, you've got young parents, they've got a small child. That's why, you know, a newborn, That's why suddenly they're buying nappies a lot, but they don't get to go out and socialize anymore because they've got small children. So of course they're buying beer and wine because they have to stay in. They can't go out anymore. So, it's very, very easy to come up with these kind of ex post rationalizations. So that's one thing we would look at. And essentially what basket analysis is going to do is, it's essentially an application of conditional probability. That what is the probability of a random customer buying a certain item? But then if we say that we know that they also bought these other items, how does it change the conditional probability? And the idea is you look at what's called lift, which is the ratio of the unconditional probability to the conditional probability. So a very simple example with association rules that's very trivial is milk and butter. If you buy milk and butter, there's a very high chance you're buying bread. It's as simple as that. Those things tend to co-occur in a basket. So that's kind of one of the things we're going to look at with association rules. And a lot of the time they're now that sounds really simple. The trick is that, you get loads of different items. So how do we figure out what to calculate? Because, from an engineer, you could do brute force on it, but that will be very slow and long. Whereas what we'd like to be able to do is come up with a better way of doing it. And there's packages in R that do this. It's called A rules. And that's one of the things we're going to look at. So those is one, and that's the one we're probably going to spend the most time on today, simply because it's the one I've probably done the most work on. It's not necessarily the one that's going to be the most useful, but it also has the lowest amount of, what would I call, statistical loading, let's say, whereas the others kind of involve a bit more knowledge of stats and stuff. And it just was the one I was the least familiar with, had heard about a lot, and I figured I should learn. So that was the one I've kind of started on. We are going to cover the others though, and I am going to kind of cover I'm going to kind of provide a quick covering of all of these, and then we're going to go back. And that I'm trying to do that very deliberately because, as I said, what typically happens in these projects is you don't necessarily know how to solve the problem. And quite often the requirements you're being given are vague. So what you'd like to be able to do is, rather than having all these preconceived techniques, you kind of use the technique that best answers the question you're trying to get. And I know that sounds like a really obvious thing to say, but it's very, very easy to fall into the trap of having one or two techniques that you like to use, and having these defaults, and that's absolutely fine. But what I'm trying to convey here is that sometimes you're like, in this case here, I don't think linear modeling is going to work particularly well, because what the hell are you modeling? You've also got time series effects. So we could use that, and we might for some things, but it really depends on the problem. So instead, what we're going to do is we're going to kind of do it, but we don't really know until we start. So instead, what I'm going to do is I'm going to kind of go over in a very effectively shallow way a couple of ideas that I've had, and then we're going to try them all a bit, and just spend, like, in practical terms, a lot of this will represent maybe an hour to maybe half a day's work, just to get a sense of how difficult the problem is, how hard it is going to be to solve, and just get a sense of the cost benefit analysis on a very quick basis. How does this work? What's involved in it? Do we foresee any challenges with it? How much are we going to get from this? Will the juice be worth the squeeze? So we'll do that. And again, I'm not going to do this in real time, but I'm going to try and cover kind of how I went about it in kind of condensed form. I was laughing. I was talking to some colleagues this morning about this, and he was saying that one of the problems is a lot of people want to learn how to learn, and that's rarely taught very well. And it's rarely taught at all because it's very hard and it's very individualistic. But what I'm going to try and do today is kind of show how I did this in a very condensed format, because as I said to the lads, we had like 10 minutes of this by accident in the last workshop where my machine started to crash, and it was kind of silent and it didn't work very well. So that's not going to make me staring at the screen and randomly clicking stuff and Googling a bunch of random things and kind of haphazardly surfing the internet to figure out what the hell I'm doing doesn't make for a particularly productive workshop for 2 hours. But what I am going to try and do is kind of go through a montage in that classic Hollywood style without the cool soundtrack, and certainly without me doing sit-ups or anything like that. But you know, just kind of showing some of the things I did to kind of figure out where I was going with this. And you know, I'm going to be honest, I love a good graph. So some of these things, it's me trying to figure out where the hell I'm going. And, you know, there'll be a bit of that in association rules. There'll be quite a bit of it in buy till you die, and less so in graph theory and time series, mainly because I'm a bit more comfortable with them, because, you know, graphs I've done a couple of workshops on. So I'm kind of getting I'm starting to grok graphs better. Time series I spent ages working on. So I'm very comfortable with them. So less so on those, but just getting a sense of how useful are these going to be, and how would this, if we were to use this technique, what could we learn from it, and how could we figure it out? So that's kind of where we're going to go. So the depending on how we get on, I'm conscious it's about 7:45 now. I'm going to stop here and ask, is there any questions? I'm checking on the chat. Does anyone have any questions for me while I go on with this? So now might actually be a good time to stop, because I didn't realize I was talking for as long as I was. But yeah, so I think what I'll do is I'll explain very quickly before we take the break at a very high level the kind of roots, I don't want to say the rabbits, but the holes I've dug, just trying to see how hard the ground is. And when we come back, then we'll kind of do a slightly more comprehensive summary of each of them. I've created 3 or 4 workshops in this here. I haven't committed any of them into the actual DDS workshop yet, which is the same one as before, which I should put up here at some point. All of this is done. In fact, let me put that up now while I'm talking about this. So there is the online retail 2. If I go into github.com, it's DDS soup to nuts, I think. Let me just bring up Kevin all. You gotta love autocomplete. So it's all in here. I haven't, like you said, 2-3 months ago, because, you know, we had a talk last month, so it's been a while since I pushed up. There's going to be a bunch of updates to that coming up at the end of this workshop. Hopefully most of the stuff we'll cover, like some of these are going to name, and I've changed the Docker file and stuff like that. But yeah, okay, so it's 7:45. I'll spend the next about 5 minutes explaining a quick introduction to the topics I'm looking at, and also to kind of explain my rationale and my thinking behind all this. So the first thing to look at was association rules. So that kind of jumped out straight away, because it was basket analysis. I try to learn a bunch of techniques. I never really learn them properly. I just want to know they exist. Ideally, what I would like to learn is something to Google, and then I can kind of teach myself what I need to learn. So association rules are one of them. It was one of like the first kind of machine learning techniques, for want of a better term, that was discussed in this. I think like the whole data is the new oil, that comment, which isn't nearly as horse shit as it sounds. It was actually, if you go back to the guy who actually said it, it came from an interview, I believe, in 2006, from a guy called Clive Humby, I think his name was, or Kenneth Humby, but from a company called Dun Humby. And they were a company that contracted to Tesco to help do some analysis on their loyalty card scheme. And he basically said data is the new oil, but the point he was trying to make was that, you know, data needs to be refined and extracted, and you know, you can't just take it out. You don't take oil out of the ground and pour it into a tank, although apparently that's something that you can do in Saudi Arabia, although it's not great for the tank. But that's how like refined the oil that comes outside it, which is why it's so valuable. You know, it requires a lot of work. And one of the things they pioneered was kind of this kind of stuff, or at least kind of productionizing a lot of it. So with association rules, it's essentially conditional probability. And what you're trying to do is figure out, okay, given that I've found, say, these 3 items in a basket, what's called the lift, which is the ratio of the conditional probability of that being in the basket, given that the other items are in the basket, versus not knowing anything about the basket. So let's say, for example, you know, it's a supermarket and 1% of baskets contain milk. But if you know the person has bought bread and butter, you know, 30% of the baskets contain milk. Well, then the lift on that item is 30 for those other items. right? So what you're trying to do there is find those items. And there's a bunch, it's not quite as simple as that. And there's a bunch of other things that need to be thought about, but that's essentially what you do. And you're trying to find items that co-occur in a basket. And that can be useful. And I found some interesting approaches to that concept that we will discuss kind of once we've gotten into it. So that's one thing, association rules that we can look at. The other thing is the buy till you die model. So buy till you die was models developed by, or at least popularized by, a guy called Peter Fader. I think he was out of the Wharton School of Business. The logic there is, it's useful in a non-contractual setting for customer lifetime value. So the idea here is a customer buys on your the first time a customer visits your website and buys something, they're considered born. They're onto your system. And the model takes the assumption that you're going to keep buying until you die, i.e. you stop being a customer. The problem is, because it's a non-contractual thing, I could come onto a website, buy something, and never visit the website again. And I'm sure, in terms of online retail, I'm sure we've all done that. I can think, at least off the top of my head, three websites at least, and probably 5, mostly in the States, where I bought something once and never went back again. And they have no way of knowing that, but maybe I will go back, and it could be 10 years later, I'll come back and buy something. So the logic there is, how do we kind of model that? And how do we do that? So they kind of look at what are called RFM models: recency, frequency, and monetary. So the idea is you look at how recent it was, taking the logic of, if someone has recently bought something from their website, they're more likely to still be alive and buying again. The frequency is, how often do they buy? So a customer who has more transactions is more likely to be a repeat customer than a customer with one transaction. And then also modeling, given that they're going to buy something, how much are they going to spend? And that's the monetary. So you kind of decompose it into these. So there's a bunch of different ways we can take on that. So those are that's the second one. The third one is kind of tied into the basket analysis and the association rules, but slightly different, and just using a graph. So my logic was, if I consider membership in a transaction, so I'll take a stock item and I'll take a transaction, and I just draw a link on a graph between the two, and then build it out that way and model it that way, and then look at, essentially cluster it and just try and find co-occurring items that are somehow related to one another. Now, that is kind of closely connected to what happened with association rules. And I'm going to look at it in a bit more detail probably later on, going back to it, but because it's been kind of superseded by the work I did on the association rules, because they essentially reduced the problem. It was a dimensionality problem, because you can model the association rules as a graph as well. And that's kind of the road down. But I think going to the original raw data and not going the association rules might be useful as well. So that's kind of I'll call that 2.5. And then the third one is time series analysis. So this could be useful, for example, if you're trying to do stock projections. So maybe do some time series of stocks, individual item sales, or just revenue projection. If you look at it on a weekly, monthly, daily basis, trying to predict how many sales we're going to get in aggregate across the whole business, or across, the top 20 or 12 or items. Now, if you do it on an individual item basis, it's probably going to be problematic, because you're going to have a lot of days where you probably don't sell that item, or maybe the item doesn't sell at all for like 9 months of the year, like Christmas lights or Christmas related stuff. And then starting in November, you sell a crap ton until the end of December. So, you only get 2 months in the year. Time series analysis mightn't be great for that on an individual item basis, but maybe if you could group it together, it could be useful. So those are the kind of the 3 high level approaches I'm going to take to this. Like I said, association rules, which I will cover, and we'll cover these 3 very, very quickly, look at them, and then I'll start going down, kind of digging the holes deeper. So that's basically what we're going to be doing in the second half of this workshop. Does anyone have any questions before we take a break? So what I'm going to do, I'm going to take a break here. It's coming up to 5 to 8. We'll take a maybe 10-minute break, come back around 5 past. I'm going to go on mute here for a couple of minutes, but I'll be back in a couple of minutes, and I'll put a ping in the chat. If people want to unmute and ask a question, that's fine, or stick it in the chat while I'm gone. Or if you have any ideas or anything that you'd like to comment on, we can address it before we start up again. But here's a good place to stop. So yeah, so I'm going to take a break. By all means, put it in the chat. I'm going to probably turn off the video, and like I'll stop streaming my voice, put myself on mute, but I'm going to keep an eye on the chat. And if anyone's got any comments, please just give me a shout. We'll see you back at about 8:05. So in about 10 minutes.
Here's the game for Tesco. I think that's the game for Tesco right there. I think that's the game for Tesco. There is a game for Tesco there.
Lovely, that's going in there now. Simply, and just mix those together. Like that. And you get this batter. If you haven't made it before, or perhaps seen me making it now, you might have thought, goodness gracious, what's gone wrong? This is the texture of the cake. Or your cake mixture, your tin, alarmingly liquid looking. Now, into our oven, preheated to the correct temperature, in this case 170. That's going into cook for approximately 30 minutes. Now, I have one that I've made ahead. It's really a simple looking cake, but it's quite handsome nonetheless. And then I'm going to make a simple, what's called a glacé icing here. And I'm also going to add some raspberries and reduce a little bit of mint as well to decorate the doors. So I'll just managed to make one size of move. Otherwise, you might have lumped in your icing and the juice and the zest of the hang alongside you. How do that? The German High Command now has plans of a new fighter, on which they'll have to waste 6 months of concentrated effort before they realize they've been sold a pump.
Hi all. So I'm back. Like I said, I'm going to give everyone a bit of time. I'm just going to mute everyone because there's a bit of background noise there. So I'm just going to mute everyone and then I'll mute myself. So hopefully you can all hear me again. But yeah, I'm going to be here for the next kind of 5-10 minutes. If anyone has any questions or wants to put them in the chat or unmute or whatever, by all means, feel free. But failing that, I will just get set up for the second half of the workshop while I'm doing it. But feel free to jump in if any of you have any questions. So you'll probably hear me mutter to myself in the background. If I do that, my apologies. This is kind of how I work to myself. And like I said, while I'm doing this, this is what I tend to do. So have a look. One thing I did mention earlier was just the number of transactions in the data. So I was conscious I'd filtered out some things. So let me just do a quick count on the invoice ID. I have about 50,000 in my head. Yeah, it's just under 54,000. Well, 53,500 separate invoices in the data, and I think I did a plot somewhere of the different count of transactions of items. I'm sure I probably have it here. Yeah, we did some checks for data integrity. Yeah, so you can see here there's a long tail that's on a log scale. So, you know, the vast majority, a very large number of items just have a single, of transactions just have a single item in there. And then we have this kind of log normal distribution of values, you know, with a long tail. I heard a comment somewhere, which I completely agree with, that, you know, people talk about how the normal distribution is ubiquitous. You see it everywhere. And someone made the comment that it's not really the log normal distribution. It's actually, or sorry, the normal, it's the log normal. And I would tend to agree with that, especially when you're constrained for something that's got a positive value. So like counts of things and that long tail. I mean, obviously in reality, a lot of them are actually Pareto tailed. But it's amazing how often things do, like a log normal is a relatively good fit, and you do get a nice long tail. I mean, it's not perfect and it's not truly long tailed, but you do get that kind of long skew from a log normal quite often. So, you know, just taking logs and then plotting the logged data can often give you a nice kind of bell curve that obviously it's not great for the extreme values if that's what you care about. But if you don't care about that stuff and you're not necessarily exposed to the tail, as the phrase goes, to quote Nassim Taleb, you know, if you don't, you know, if the tail isn't going to kill you, then quite often, you know, a log normal is quite good. You can do a pretty reasonable job on that. So does anyone have any questions for me while we have the 5 minutes? It's good to see some famous or familiar names in the crowd. A couple of people I actually have been meaning to mail for a while. You know who you are. My apologies. I've been a bit crap the last couple of weeks. And a couple of others who, yeah, just familiar. I don't see any questions, so that's good. I'm just going to make the wild and strong assumption that people who are not asking questions mean I'm absolutely nailing all these explanations, and no one has any questions at all. So that's brilliant. Yay me. To be fair, we haven't covered anything particularly complicated yet. I'll talk about this a bit at the end, but we don't have any speaker. We had a speaker last month, which is why it's been 2 months since the last workshop. I don't have any speakers lined up for May or June. I'm hoping to get a speaker in June. I'm not sure how amenable, how it'll be available, but I'm hoping to have a couple, and there are a couple of people I'm hoping to follow up on. And I'm not sure how many talks we'll get between now and say the end of the year. It may be just workshops. If it is, that's fine. It doesn't matter. I've got a few topics I'd like to cover anyway. Yeah, and I'm just going to keep doing this on a monthly basis while the unfortunate reservoir of speakers has dried up due to COVID. Because like I said, our standard recruiting technique has been to, you know, basically mug someone at the bar who's just had the misfortune of saying something interesting. So the universal refrain from ourselves and our main organizers is, that sounds great, would you give a talk at Dublin Data Science about that? So obviously, you know, the fact that we can't go to the pub and you can't really do these things in person has kind of curtailed that quite a bit, which is why we just haven't had very many talks in the last year. I think we've had 5 or 6 in the last like 13 months. So that's why I've just been running workshops. I've been thinking as well about how we will kind of do this in the long term. I actually kind of like doing workshops online, and you know, we had to go upstairs in pubs and stuff, and it was always just a bit hassle, and it would effectively limit the days because, you know, it depends on what app, you know, what was available. So what I'm thinking I might do long term is for these kind of is keep doing the talks in person, but just do the workshops online and like maybe record them and put them on, and we'll end up after a while with a nice kind of repository of workshops and topics that, you know, will actually kind of make for hopefully a decent, you know, set of videos that could be useful to people. I don't know. I mean, maybe they're too long and rambling. I'm not sure. We do seem to get a few viewings on the YouTube videos, which, to be honest, surprised me, because I thought it would just be me, but it does look like a few people. And I checked, and I think you have to have watched at least a few minutes for it to be counted as a view. So I'm not quite sure how that works. But yeah, so that's kind of where I'm thinking we'll do the talks in person, but the workshops will probably move online. And it's nice to be able to cover, you know, like basically global geographies. Actually, on that note, would people mind just pinging what country they're from, especially if they're not from Ireland? I'm always curious to know what our kind of geographic cover is. I'm conscious some people are calling in from London and stuff who I know, but if people are like abroad and not in Ireland, that's one of the great things about, you know, not being able to do these things online. I know most of the people are from Ireland, but I think we've had a couple of people from like Turkey and Brazil and stuff in the last few workshops, so it was great to have that. Cool. All right, what time is it? It's all. I'll give people another minute and then we'll start back up. Where is my association? Quick drink. Okay, let's start back. Okay, so as I said, we are we're going to look at association rules first. So we're going to do some basic basket analysis, and there's a couple of very good packages. There's actually a few packages. In fact, let's start with that. So if I go on to CRAN, like I said, I'll just pop that in there for people. We have all of this is in a GitHub repo. So this is kind of like, I have my old data workshops repo that those of you who have been to my talks before, that's kind of what I work out of. But just to try and keep things kind of more current and fresh, what I'm doing is I'm kind of copying the work from there into this repository, and this kind of goes along as we cover the workshops. So you'll see this kind of evolve over time and not necessarily exactly matching what's in the other repo. That's kind of my logic for that. So if any of you are interested in that, I'll just copy and paste it here just to make it easier for you as well. That's kind of the repo for this project specifically that will be updated like after each one. So you can see there's like 2 or 3 months ago before some of these files were updated. So, you know, most of these will be changed as of probably 9:30, 10 o'clock tonight when I commit some changes and push them up. So if any of you are interested in this stuff, all this stuff will be available there. So we'll go on to CRAN, which is the Comprehensive R Archive Network, which is where most of these packages are based. You can see there's A rules, which stands for association rules. And then there are a bunch of, you know, packages. Reverse depends is handy there. These are the packages that depend on A rules. And you see there's a few of them like A rules CBA, A rules viz, A rules sequences. There's a whole bunch of things in there. They might be worth looking at and seeing if there's, you know, because they build on the basics. So that's always handy. I find those things are particularly useful for this stuff. So, yeah, there's a pretty good basis for this. Just to address a quick question that no one has asked me, but I am conscious of. How did one of the things I do try to do as a kind of a matter of course is I try and find out roughly if I hear a topic that data science or data or statistics uses and I don't really know what it is, I do try to make it my business just to kind of figure out what it is. Like 5 or 10 minutes, not a lot of time, but just if you're on a break, satisfy the curiosity because it kind of sticks in the head then. And then when it comes up later, it might be useful and it's something you can save yourself a while Googling stuff because I know that these things can be done. So association rules are one of those things that people mentioned. I just kind of filed it away. And to be honest, one of the reasons I chose this data set was because that way I could use association rules on them and it would allow me to learn this stuff. And similarly for buy till you die, people have mentioned them. And I was working on customer lifetime value in a contractual setting where we could use things like survival analysis and other workshops on. You can look that up if you'll see it in the data workshops repo. if you're interested. But in a non-contractual setting, it's actually an interesting problem as well, because you don't necessarily have that strong, you know, with a contractual setting, you can tell, you know, was the customer active? Well, did they keep paying their invoices when they were supposed to, like on a monthly basis or annual basis or whatever? So that, you know, that's a very different idea. So I'd heard about these BTYD, and a couple of friends of mine had used them and kind of said, you know, they were very happy with the results. So, you know, that was it. So that you kind of file these things away. And I just kind of make a point. I'm on the R bloggers as well, that I just get an email every day, and I don't really look at it, but I look at the headlines. I don't read all the articles, but I do find kind of, you know, storing that junk in the back of your head can be very useful. It can kind of really be a massive time saver lately, because it just kind of accumulates in the back, and you at least have a starting point, which is often the hardest thing to do. So that was kind of where I got these ideas from. I'm sure there are more. And if anyone has any ideas for this data set, or has like something I'm missing that's obvious, please shout it out or drop me a mail or whatever. I'm happy to look this stuff up, and it can be kind of a topic for future research in maybe a future workshop that in this series, depending on how successful it is. I'm happy to look at it. All right, so I kind of wrote this stuff up, and I put a bit of text in here as well to help with it, mainly to help myself remember this stuff. So the first thing I kind of hit immediately was the A-Rules website. It didn't really tie in well with the tidyverse, which I pretty much use for all my stuff now. And that's another problem with BTYD that I'll mention in a bit. So one of the things I had to do was essentially write out like the transactions data in the CSV in the format that A-Rules wanted. And then I read it in using this read transactions, and it creates this very specific data set that we can then use, and it's plotting like item frequency. So it's the relative frequency of various items. So you can see here that like this product code 85123A is in about just about 12.5% of the baskets, and so on down. And then there's an absolute plot where it plots the absolute value. Stock codes don't mean a huge amount, so I wanted to look at them. So you can see like lunch bag red spotty, lunch bag red retrospect. So you've got all this kind of weird thing. Another thing that did occur to me actually was it might be worth doing some kind of word cloud or some kind of really, really simple NLP on this description field, just to see, is there anything we can do there in terms of, because there is no kind of product code hierarchy in our data set. It's literally just a stock code. And that might be useful for things like time series analysis or clustering, where we could get like types of items together that isn't necessarily represented by basket analysis. So that was one of the things to look at. And then, you know, I'm looking here at association rules and just what they did. So there's a thing like a support. So, you know, you have an item set, which is a collection of items that co-occur. You have the thing called a support. It's the proportion of transactions in the data set which contain it. So it's like essentially the relative frequency, the proportion of transactions that contain those items in them. And then you have the confidence of a rule. So you have a rule then, which is basically a directed relationship of, you know, given that we have these one or more items, implying that we have this third item, right? So for example, you can see here on the page, you know, milk and bread, you know, implying butter. So that means essentially the confidence of that is like, it's the ratio of the two, it's essentially like a conditional probability. So given that we have milk and bread, what probability do we now have of seeing butter? And that is 0.5. So that's essentially the conditional probability rule. And then we have the lift, which is basically the ratio of the unconditional probability to the conditional probability. If the lift is greater than 1, it means having these items means it's more likely to see the item. If the lift is lower than 1, you're less likely to see the item, given that you've got them. And usually what you want to look at is positive association. So, you know, given that we know them. Now, one of the criticisms I have heard of association rules is that they often tell you things you already know. So for example, you know, if you go off and do a bunch of fancy data science and come back and tell people that, well, did you know that if you buy milk and bread, you're a lot more likely to also be buying butter? you know, you're going to get laughed out of the room if you tell them that. But what I did find it's useful for maybe is finding the ones that have slightly less lift and support. So kind of rather than, you know, the very obvious things, because they're the things everyone will know, it might be more useful to look at the middle of the range, like say from, rather than 0.8 above, looking at from like 0.4 to 0.8, because there you're finding weaker associations, but they're also maybe less obvious. So therefore they might be more novel to the stakeholders that you're talking to. And that might be of interest to them, because it's not necessarily something they will know in advance, because the signal may not have been strong enough to be detected by humans, if you know what I mean, in terms of the pattern. Whereas, so it might be more, obviously you don't want the complete nonsense down in the bottom where there's no support for it at all. But like, I do have this gut instinct that looking at that middle level people, the middle level rules, where the support isn't very, very strong, but is kind of middle, might be of interest. And that's kind of where I kind of was looking at. So the question is, how do we do this? Like, how do we calculate these rules? So there's a couple of different algorithms. One of them is called the a priori one. I haven't really looked at it, but it's essentially, it's an efficient way of searching for these conditional probability rules, and you pass it like a minimum support. So in other words, you know, the items we're looking at have to be at least, you know, 50 basis points, like 0.5% minimum, like they have to appear. So that like the higher this number, the more rules you filter out. The problem with it is if you've got, because we have like 50,000 transactions in this data set, you kind of have to have your support reasonably low. But then the confidence is also, you know, what's the conditional probability of seeing these items? So I've just set the minimum confidence of 0.8, and we're going to look at it. So the output of the a priori rule looks like this. We have found 423 rules, and now we're just going to turn them into a data frame and look at them. So you see, we get the rules, so that it creates this string. So basically, given that we've seen 22917 and 22918, what's the effect on 22916? Now, immediately you can see the issue here. All these stock codes are beside one another. So probably they're entering on the system at the same time, and they're all kind of similar. So maybe we're busy, we're going to spend a lot of time and effort digging out things that are obvious to the end user, which isn't necessarily what they want to know. You don't necessarily want to be telling them things they already know. Although the counter argument to that I always have is, yes, but you've been working in this business for 10 or 15 years. I've been working on this data for a couple of days, and I'm telling you things about your business that are obvious to you, but there's been almost no investment of time and effort for me to learn these things. And that is the power of using data for this stuff. So that's the counter argument I tend to come up with when people throw that at me. It has mixed success. Some people just don't want to know and they're not interested. That's fine. You're not going to convince everyone. But, you know, to me, that's actually a very powerful thing, that you can, you know, find out the obvious stuff really quickly. So, yeah, so that's based. So I'm going to scroll down this quickly because, like I said, I don't want to spend too long on this because there's quite a bit of work we can do here. And I'm going to come back to it, but I want to kind of, so that was one thing I looked at, and I did a quick kind of, I can't remember how long I spent, a couple of hours playing around. I went on to CRAN, I looked at association rules. There's the introduction to A rules, which is quite good, actually. One thing that's definitely happened as a trend is the use of vignettes to document it. So now, rather than just getting this bloody man page up here, the reference manual, that's basically this really dry, you know, here's what the parameters for each function are. They don't really tell you like a complete newbie guide to the package. That's more what the vignettes do. So you can see here an introduction to A rules, and it's about 38 pages. It's quite good, and it goes through all the basic theory and stuff. And basically what I put up on here is a summary of this. And it, you know, it explains all the different things. Not all of this you need. I kind of went through a lot of this crap and went, I don't want any of this. All of this kind of data processing stuff is good, but I don't need it because I'm going to do all my stuff in the tidyverse anyway. I just want to learn how to use the various packages, the various functions and stuff in there. And they use a lot of base R stuff, which I just can't stand. It's all this like item array indexing and stuff. And it's like, no, I did that 10 years ago. I'm not doing it now. You know, I've done my apprenticeship and I'm not entirely sure it was that valuable. I'm just going to leave it. So, you know, I went through all this and okay, support A rules, the a priori algorithm, you know, let's find out. The other thing I found out, which was really useful, is this A rules viz. That immediately, so like visualizing association rules, that immediately got me interested. There's a vignette for that. That's good too. What can we do with that? And graph-based parallel coordinate plots. That's all quite interesting. So I kind of looked at all of these and I went, okay, so maybe we can build up some association rules. Maybe we can plot them on a graph, start to visualize it, and I spent maybe, I can't remember, like I said, exactly how long I spent. Where's the graph-based visualizations? That kind of got me interested because you can start to see, if we scroll down here, and this was kind of where I went, oh, look, we can start. So these red squares are the rules, and then we've got the various products and that they're linking to. I was like, okay, this is quite interesting. Now, unfortunately, our data isn't as useful because we're using stock codes, so they don't stand out as much. It would be better if, but maybe some of the stock codes are just too long and your graph would end up being a bit of a mess. But this is kind of used. So you can say like instant food products, also hamburger meat, soda, popcorn. So okay. So now maybe not necessarily looking at the tables of numbers, but if we can plot our association rules on a graph, that could be useful. So I kind of got to that point with the data set and I left it then. And I thought, okay, this is useful, but again, I was a bit burned from the returns thing and the stacks and all that stuff earlier. I thought, no, I'm going to stop here because I know this is useful, but I want to see what other options I have as well. So that's where I kind of stopped at that point, but it kind of triggered the idea of a graph analysis on me. So the other thing I looked at was exploring the graph data. So kind of opening this up, and let me open the rules here. Where is it? It should be there. Did it not render? Yeah, there we go. So I kind of took the idea of, rather than going the association rules, and this came off a comment from one of the previous workshops, I thought, well, maybe if we do a basket analysis whereby, let's look at it here. So we have, we essentially have pairwise. So rather than do the full association rules, let's just look at some pairwise graphs. So basically, we look at a stock code, and then we look at every other stock code. And basically, by invoice, we just create a pairwise graph, and we can filter out the symmetric ones. So we just do them in, say, alphabetical order, so that, if we have A and B, we don't also have B and A, and also we don't have A and A. So we just make sure we just use less than, and that's why I went filter 1 less than 2. So it just does alphanumeric sorting on it, and then just create a big graph. So we can see here we have this, we have for every invoice where there's more than one, at least one item, we're just creating a set of pairwise. Now, the problem with this, of course, is it scales terribly. Let me just run it while I'm here, just to illustrate it. Markdown, render, exploring graph data. So the problem with it is that it's essentially n squared. So when you have baskets with n squared items on them, they basically blow up. Now, what you can do is filter them down, because if you have transactions that have the same pairing on them, obviously that will be a duplicate. So you can eliminate that and just keep the distinct ones, but you still end up with a graph. So in this graph, you will have every node is a stock item, and the edge between them dictates that, basically shows that these two were in the same invoice together. They were part of the same basket. And you can see there, yeah, I'm using for, which is the future and futures and per, which basically allows you to scale across multiple cores, because it was just doing it in serial was just taking bloody eggs. I'm not really going to go into that, but the code is all there if you want to look how it does. It's very easy to use. It's future underscore, and I had to talk about this earlier, where I did talk about. Actually, I don't know if I did. That might have been to a different group. Anyway, so yeah, so the idea is you have your graph data. So, and then there's a thing called tidy graph and iGraph, which is these things in R. So you have basket graph. I'm making it undirected, but we can see here we have, we have basically a million edges. No, 994. Yeah, so we have about 46,000 nodes and about a million edges, because every item becomes a node on the graph, and every edge is basically a correlation. So while the association rules was nice and gave us graphs, and this is a nice idea because we're not reliant at all on association rules, I kind of quickly realized that this is probably useful, but only useful if the association rules gives us value. So like what I'm going to do is, like I said, we can visualize the association rules as a graph. And if we get some good juice out of that, then maybe it's worth going back to this method and looking at the whole transactional data set and you know, managing it that way, so that at least it'll be better in terms of how to deal with it. Yeah, I'm because of the scaling issues here, it kind of gave me a bit of pause. So this is going back to the point I was looking at. And like I said, it's a messy process. I kind of looked at it and I thought I could end up solving engineering problems here, trying to get this bloody stuff to work. And yeah, it's only 1 million rows, but I might end up just, you know, running out of memory and having to pare the thing down. And is it actually going to tell us, are we going to learn more from this, like a lot more from this than we would get from the much smaller graphs I'm going to get from the association rules? So I thought, let's just stick a pin in this. I spent, you know, there's not a lot of code there. It represents maybe an hour or two's work. I kind of thought, no, I don't want to end up solving a whole lot of engineering problems that don't really get me much. So instead, what I'm going to do is I'm just going to stop here. I've kind of left it, and I've left the code there. I haven't deleted the workshop, the worksheet or anything, because it's something to fall back on. And as you can see, there isn't even a lot of text in there. I mean, I've put a bit in just to remind me for myself. And I put that in because, you know, this is more for future me rather than other people. It's like when I go back to it, I've kind of got a memory of what I've done, so that I can kind of get back up to speed pretty quickly. And that was a trick I learned from actually Hadley Wickham, the guy who did the Tidyverse, because some people are asking, how does he be so productive? Because he's just done so much stuff. And one of the things he says is because he always writes stuff down, it's more for him than it is for other people, because that way he kind of remembers what he did, so that when he comes back, you know, because he'll find out, oh, I did something like this a year and a half ago. What was it? And then rather than having to relearn it all, because he's put it in our markdown document, he can kind of remind himself very quickly and get back up to speed. So that's kind of what I'm doing here. So this is definitely something I want to look at a bit more, but kind of a certain amount of discipline in self being chastened by the whole returns thing. I thought, no, I'm going to stop here. I'll look at it later if it's useful, but I'm going to leave it at that. Okay. So that was kind of like I said, this is kind of the half method I've looked at, because it's kind of associated with association rules. But I wouldn't say it's a full approach that's separate. So that was two things I looked at. So the other thing was, like, kind of struck me straight away, was just time series analysis. So I'm going to go back to the exploring data for this. So I had some data in here, like exploring time series database data. So we can just create like univariate plots. So in here I had data, kind of I aggregated it daily and then just plotted the total amount spent. So now this wasn't necessarily filtered for returns, so I should probably filter this out, and I do in the other workbook. But yeah, so like looking at it on a daily basis, then on the total spend by week and the total spend by month, so you can see the numbers go up higher. But you know, we can see there's definitely seasonality here. So you can see there's a big spike around Christmas, and we discussed this before. That made sense. We looked at kind of the modeling. You can also see on the daily basis, there's these kind of straight lines at various points. You can see here and here. I don't know if you can see my cursor. What basically happened was we looked into the data. There are some sales on Sundays, but not very many. That kind of gets obscured. But also the business seems to shut down around Christmas. So once it goes to, I think, the 3rd or the 24th, depending on when Christmas fell, it basically doesn't reopen again until essentially early January. So in around the Christmas period, there's 10 days where there's no transactions whatsoever, which I thought was a bit curious, because it was an online retail, but maybe it's an online presence of a brick and mortar business where they're only kind of they only do sales, like, and they effectively shut down and don't really take sales. And I guess nowadays that probably is less likely, because even if you're, you know, essentially not fulfilling orders over the Christmas period, you're still probably open for business in terms of, you know, you just hang a sign on the front page and say, you know, we're going to fulfill the orders in January. So you might make a sale on the 24th, but you don't actually fulfill it until the first week in January or whatever. So I thought that was curious. But like I said, it was 2009, 10, and 11. So even the web was and e-commerce was still quite different back then. So that might kind of explain that, but that would be definitely something, if I had access to the stakeholders or the owners of the data, that would be a topic I would be asking them about, like, what's going on here? Is that right? And, how do you mitigate against it? Or can we factor into our now? Because the other idea is to maybe, for the purposes of modeling, you just say those dates don't exist. And you just say, for the purposes, and that's what often happens in trading, for example, for the purposes of trading, it's a 5-day week. So you go from Friday evening at close to Monday morning, and that's basically one day. It's not 3. And, there's different ways of handling that. So you have basically a year is 252 trading days rather than 365, allowing for holidays and stuff like that. So yeah, maybe we're going to have to do that. The other thing it would be interesting to look at, though, would be to maybe, and this is something, again, actually, let me bring that code up. I have some code for this. Initial times, and I'm saying initial models because I don't really want to, I'm not saying I'm building full models. Like I said, these are kind of digging a bit into the ground just to get a sense of how frozen the ground is and how easy it's going to be and how likely we are to find treasure if we go down, dig the hole here. So, doing some basic things. There's a really good package called Tidy Quant that kind of covers a lot of this stuff. I thought this was very interesting. This was kind of where, one of the things we're going to do. I won't go belabor this point. We've tried, and then, but maybe just group by most frequent items purchased and do a time series of those. Maybe for like stock projection or figuring out, stock levels, figuring out how much a particular item is going to sell. That could be useful. So we've looked at that. The other thing I might do is building in some dependency. So if we get like clusters of stock items from the association rules, which is something we did, and I'm going to talk about that very shortly, maybe we just group by those clusters and we aggregate all the sales by clusters and then use that to project. And that might be useful as well. And that there might be like looking if that kind of makes our sales more homogeneous. That could be something useful to the stakeholder as well. I'm not sure. Like I said, I'm just kind of throwing up ideas. And then the final thing is to look at what's called buy till you die models, like I said. So we have a couple of things in here, and there's initial BTYD. Where is that? It should be in here. There we go. And again, I have our markdown files for all this. So the buy till you die models are a bit weird. So, and one of the issues had, as I mentioned, with A rules, I went onto there, and there is a package called BTYD. Buy till you die, and there is a walkthrough on that. This was kind of one of the problems I have with it, is that it's a bit old school. So it's doing a whole load of stuff that the tidy, basically they need to make this package, or ideally if I was to do this and I found this was useful and this was something that the customer, or I was working for a company that wanted this, I would probably spend a bit of time making the buy till you, making maybe a new package that basically incorporates the tidyverse with buy till you die, because they kind of reinvented the wheel for a lot of this stuff, and I found it a bit irritating and kind of harder to use. So basically the logic, and so I went on this, and this is kind of the overview on here, and it's okay, and it's written in a PDF rather than HTML, which again kind of dates it a bit. When did they last update this? By the way, November 2014. So you can see, I mean, the tidyverse was around back then, but it hadn't become pretty much ubiquitous. And I know a lot of people don't like the tidyverse. Some of them are purists, because it is slower and it does come with a computational overhead. But it just makes this work so much easier. I can worry about performance later. The whole Donald Knuth thing of premature optimization being the root of all evil, and that is very true. So, the thing I care about the most is how much time I have to spend at a keyboard and how much work I have to do to think. And a lot of this data is just data prep and converting the data into the format the model uses. The other thing I would like to do is make this Bayesian and create like Bayesian models of this. Because to me, there's a very natural hierarchical model that you can build here. So that to me screams out Stan. And that's something I might actually do as a separate workshop series once I'm done with this. I think there's a lot of interesting things in buy till you die. But the basic logic is that it's essentially, you decompose the problem into two processes. So when a customer comes onto the website, they are born, and essentially you then give them some kind of counting process for how many transactions they're going to make. And you can model the Poisson. Let's use a Poisson process to make it nice and simple. I think most people use negative binomial because negative binomial seems to be more common because it's over dispersion. So that will then tell you, so you kind of start at the first process, and then you basically model how often you're going to make repeat transactions after that. And that's going to be modeled by like essentially a frequency model, negative binomial. But you also have a process by which your lifetime, how long are you, quote, alive for before you die? And that is modeled by different processes. And there's a Pareto one. So one of them is the PNBD, Pareto negative binomial distribution. Then there's also a BGNBD, which is a beta gamma. So you model your lifetime as a beta gamma distribution. And then your frequency model is done as a negative binomial. So they have a few different of these kind of what are called BTYD. There's also and they discuss them here. I've had problems with this so far. Now I'm going to be very honest here. And I kind of wanted to show this. I haven't quite figured out how this works yet because some of it doesn't make a lot of sense to me. Basically what I found was the frequency part of the model was very good, but the probability of a customer still being alive seemed way too high when I fit the models. So I kind of ran through, I kind of walked through the data, and basically what I'm going to have to do to this and try and figure out how to get this to work, because I know these are good. And one of the reasons why the question is it actually worth doing all this effort? But these are pretty standard in the industry now. So I think it's worth learning and they're worth using, because it's kind of become a fairly standard approach. It means people kind of speak that language. So people understand buy till you die models. And there's a guy called, like I said, Peter Fader, who has kind of pioneered or at least popularized these. I think it goes back to the 70s. Interestingly enough, buy till you die models, the initial paper talks about customers in financial markets, actually. And it was essentially customers at a broker, and they might put orders in. And what you're trying to do is figure out how likely customers were to put orders in with the broker. So whereas, I mean, it seems to have kind of gone away. I mean, in my experience, maybe just because I haven't really been at the retail end of capital markets, I hadn't heard of these models at all. It seemed to have crossed over into more traditional, like e-commerce style businesses, which is where they get more commonly used now. But I just thought it was quite interesting that originally it was like capital markets people, because that's my background. Sorry, I'm very conscious that I'm talking a lot. So, yeah, so the idea is you decompose it down, you do some model fits using like maximum likelihood estimation, and then you plot it out. The bit that's kind of thrown me is when I use this on my own data, and I'll show it here, because I ran the code on it using buy till you die. We kind of built the model, and this was pretty good. I fit a beta gamma negative binomial. I would normally use a Pareto because I would have thought you'll have this long tail. The problem is because there's only about 2 years worth of data, the Pareto, fitting a long tail is just crappy because there's no long tail there. It's basically 2 years worth of data. So it's all very censored. So the Pareto, I think that's why you have so much instability when I fit those long tails. So I went back to a beta gamma. So this is kind of a calibration of within the fitted data set. So this is like an in-sample fit. And what they've plotted is how many customers had 0 transactions over the period of time so it's kind of actual versus expected. So there's the model, what the model says versus the actual. So you can see it's not bad actually. So we've estimated, almost, about 1,300 customers versus 1,300 observed. So it's a pretty good fit for the data in sample. What we're going to do now, and this is the other thing, that the data structures are weird and they don't do a lot of the work for you. Like I would have expected more higher level kind of API style functions, whereas they seem to just give you very low level code that you're then kind of expected to assemble together. And it's not very easy to read. So that's kind of, I spent a bit of time on the association rules and not as much on this because I had problems with the Pareto fit as well. But, and then you can see here's the transaction rate. So this is kind of the expected, you know, per customer, how many transactions they would do within the calibration. The bit that's really weird is the dropout probability. So you can see here, basically, the probability of dropping out is tiny. So they're expecting that almost all customers on the books are still alive. They just basically, they don't drop off. And that just doesn't seem right to me. So I think I'm doing something wrong. I think I'm either haven't set up the data right, or there's something I'm not accounting for. I haven't quite figured it out. And that would be another reason for going to Stan, actually, because to me, it's much easier. I can just write out the probability model in Stan and model it directly, and allowing for all the fits and stuff. And if there's problems with the model, Stan will blow up. That's the other great thing about using the Bayes system, because, you know, Stan basically, it complains loudly if your data and your model don't really fit well together. Stan kind of explodes. So that's kind of where I think that was a very quick kind of overview of kind of, in about half an hour, of the kind of the 3.5 main methods I'm thinking of going. And I'm conscious it's about 20 to. So what I'm going to do here now is go back to the association rules and just see where we're going to go with it. And then in the next workshop, what I'll probably do is split 50-50 with a bit more on the association rules and probably on the buy till you die. And I'll leave the time series maybe for again, or maybe get rid of them completely, depending on how many people show up. Like I said, if I'm not doing this workshop, I'll have to be doing a different one. So it's a question of, do I think, and like I said, I do want to kind of complete this to the end. So I'm just going to kind of see how long it goes rather than arbitrarily cutting it short. Okay, so we're looking at the association rules. This is, by the way, this is a handy thing I've built into my Docker containers that just build, because what I've built is I've got all these workshops in there, and in my make file, I've put in a dependency structure. Apparently in R, you can do it with Drake, and I think there's something in Python as well. And basically what I've said is that, like, this workbook depends on this workbook. So for example, retrieving the data is the first one. That's the one that goes online and downloads the file and saves it and does the Excel processing. Then we do some basic exploration that kind of parses the data and creates it. And then the other workshops depend on that initial one. So the great thing about this is if I go make all -HTML, it figures out the dependencies for me and just constructs all those HTML files. So I can do a complete download of a completely empty repo, then just go make all HTML, and it will just burn all the HTML files for me and just do them in the right order, and you don't get, you know, it does it all for me. So it's a nice kind of pipelining system, and I can just go make dep graph. It's all in my make file, and it's built into the Docker container. It just creates this little graph for me. And by the way, it creates it as a dot file, so I could load it up and actually create some graph stuff with it in R or Python or whatever as well if I wanted to. I just thought I'd mention that there's a thing called make file to graph that it just does it as part of the Docker build. So I thought that was nice. So I threw that in there. Okay, so that's, let me just see. So that's the time series. That is that. And again, I'm keeping an eye on the chat if anyone has any questions. There's the buy until you die. Let me close that. So the association rules. So like I said, we have a couple of ways of doing it. We have these a priori, so they and eclat, and I don't really know what they do. They give you slightly different things, but in my experience, they've two different methods of creating association rules, and the rules they gave me were basically the same thing. They gave us almost exactly the same numbers as well, presumably because effectively they're more efficient ways of calculating the conditional probabilities, of finding the ones, rather than just brute forcing everything. So it kind of makes sense because, you know, no matter how you go about it, the conditional probabilities are going to be the same unless you're doing some form of approximate inference. And they don't seem to be doing that. They seem to be just figuring out what the most important was and not wasting a whole load of computation effort. So I did some comparison there, and they basically gave us the same numbers. And that was me just comparing them with the various suffixes. So you can see we're basically getting them. They give the same string. So I was just basically binding on the string and seeing if they give us the same numbers. The other thing I did here was, like I said, by going at too high a confidence of 0.8, I was conscious of only finding rules like, you know, bread and milk implies butter. So I thought, rather than looking at 0.8, let's look at much lower confidence. So I set the confidence down to 0.4. And it gives us a lot more rules. We now have 5. almost 5,000 rules, but I think we're a lot more likely to get interesting stuff. And I just did a quick plot here. And again, I have no idea of this use, but it's the confidence of the rule by the lift of the rule. So confidence, so you can see you've got these really high values up here that are given as very high numbers, but we kind of have all these ones down here. But the really interesting thing was converting them to the graph. So this comes from A rules viz. So the idea was to plot them out, but you can actually capture the output using iGraph, and that gives us a graph. So now we have a graph that we can look at, and you can see here, I think this actually zooms in. Let me just see. Is this the one? I put in a few, and you can see we get, oh, here we go. So I now have some graphs in here that have some nice overviews. So you can see this is basket. Let's see, let's just zoom in here. So I thought this was nice. This comes in as part of HTML widget. So what we see here is we have this little cluster. There's only 4 items in it, but there's a whole bunch of rules associated with it. But this gives us a nice separate cluster. So now, even though I don't know any of them actually appear in every single graph, we can kind of look at this separate component of the graph that we produced. And these now form effectively a cluster. So we now have a cluster around these items. Now you can see here it's 22697, 22698, and 22699. So they're sequential, which suggests they're all kind of the same thing. But we do have this 22423 that a lot of them appeared on. So, you know, basically we're essentially clustering all the products from a basket analysis. And, you know, okay, in terms of the bigs, because the rules are also items on the graph, we can kind of filter out those. And this gives us a very nice kind of clustering that we can look at. What's this one here? Yeah, 2239, 2238, and 224. So that's probably not particularly interesting. And that is from just looking at the top 30. But we can do that for more of them, right? And connected product labels. So, and we get all these here, and these are all disjoint subgraphs on the main graph. So because I used component, this is what component ID does. Where did I do that? Hold on. Yeah, group components. So it looks at the completely disjoint graphs on the, we create a graph, we have all these just disjoint components, right? And now we can look at, basically label those components by a number, 1 to whatever, and these all become separate. Now we end up with one big subgraph, which has these 61 products in them. And then we have one with 10 and 6. But then it occurred to me, okay, well, these are like clusters. So already from the data, we may find some interesting groupings of products together based purely on the transactional data, right? And while some of these are very sequential and maybe they're not very interesting, maybe they're not. Let's look at them. And that way we can go back to the customer and say, all these items tend to be kind of associated with one another. Did you know about all these? And if they did, great, we move on. But we also have this big cluster graph of 61 here. So what we can do with that is they're not disjoint, they're all connected on the graph. But what it might be, we can use a bunch of different clustering routines to cluster them separately. So when we do that with this subgraph, well, now we have 14 products and 15 products, 5 and 6. We have a couple of singletons, that's fine. But now basically together, we can create a network that isn't. Now, I couldn't unfortunately get this to render. So what I did was I put the code in here. I'm pretty sure it's in there. So let me just run this. Oh, it didn't run it. Okay, hold on. R markdown, render, initial A rules models. So what we can do here is visualize the graph and start to look at, you know, how do these models work? And then ideally what we can do is maybe check the validity of them. So basically what I started to think was, okay, well, we've got a bunch of clustering here. Some of them are from because they were completely disjoint clusters, but just in general, what I wanted to look at was for the various groups. So we have 2 sets of groupings here. One is from the disjoint clusters and the other is from that big graph of 61 groups. And I did a clustering on that subgraph. and then created basically like grouping labels, I've called them, and I've added the number, so all one, and some of them I think is all and what did I call them? An LRG for large, right? And then just plotting, given that we have what was the proportion of the cluster appeared in a different group, just to see. So, in these, it's not very interesting because there's only two groups. There's only two items. So that your options are 0, 50%, and 100%. But it kind of gives you a sense of, how, given that we have groups, we wouldn't necessarily expect to see all the items in the group. But we might have items where, a whole bunch of them appear at once. And that kind of gives us a sense of validity around the clusters, particularly for the LRG ones, because they aren't necessarily disjoint. So we're kind of getting a sense of how good is the clustering. And what my logic is then is, now that we've kind of clustered our product groupings based on nothing beyond transactional data at all, this kind of gives us a labeling that we can apply to these particular stock items that might be useful in other analysis later on. Okay, so yeah, so just from looking at the association rules and not really paying attention to the lift or the support or anything, we haven't really looked at any of the numeric data. To me, we have some interesting labeling that we can use that might be useful in other analysis later, or just feeding back to the customer to say, these items tend not basically directly purchased together, but you have this item here are purchased with these items, which are also purchased with these items. But maybe there's a thing to be made by, the transitive property. If you want A and B, and you tend to buy B and C, well, then maybe you should make an offer for A and C together and see, does that have an effect? Because they're not co-occurring together in a basket, but maybe that's just a question of how you're advertising them, or like, can we change customer behavior? And or maybe they just don't co-occur much. Like maybe they appear in the baskets, but not enough to really generate a strong association rule. Or maybe they're just nonsense and they're just conflicting, where you've got something, sometimes you need A and B, and maybe you need B and C, but A and C together are like conflicting, and B is a common thing. So, I don't know, that's something that I'm just trying to get the data to tell me. So that's kind of where we're going with the association rules. So that took a bit of time, and I'm conscious, wow, I didn't get as much done as I thought I would, but I was kind of okay with that. So basically where I'm going to go over the next probably month, because I don't think, like I said, we don't have a talk lined up for May, and we probably won't at this point. So what I'm going to do over the next kind of couple of weeks for the next workshop is we're going to look a bit more at the lift of essentially looking in the middle of these rules. There's a crap ton of rules in here. And essentially what I would like to look at is at the graph here, the highest lift with these middling supports. So you can see here, in some cases, we have a lift of 50 or 100. So basically here, like the rule confidence is only, like 62, 63%, but the lift is 100. So these are rules down here that, might be too weak for people to learn from, because they just don't co-occur enough to really make them stand out on a systematic basis. But these down here, where it's a combination of, middling rules confidence and high lift, could be quite useful. It means basically that, while they don't occur that often in the baskets, in terms of the co-occurring together, 40% of the time, 50% of the time, maybe I'll go lower. I might go down to 20%, because that's still relatively high co-occurrence for the purposes of finding stuff out. Because, the computer is just going to do it. It's not that big a deal. But then this combination of high lift might be of interest, and let's just see. And then what I would like to do is maybe map it back to the text fields and just see what kind of patterns we can get. And are we denoting it? Now, I am kind of hampered here by the fact that I don't really understand these products very well. And I've looked, like the data, it's just not described well. I don't know where this data came from. One thing I do need to do, and I'll probably do in the next one, is these were quoted in certain papers that use this data set. I might have a look through those papers, see if I can find them online, see if there's anything in the description or in the thing that will just give me more information. But my gut feeling is that there isn't, that it'll just be a very cursory item. And then because it's academic papers, they're going to focus more on the modeling than they are on the actual data descriptions themselves, which is something that's unfortunate, but effectively unavoidable. All right, well, thank you very much. I've gone a bit longer there than I usually would like to, because it's about 5 to 9 now, but I'm going to leave it there. Like I said, when we come back next month, we're going to discuss association rules, and we're going to talk a bit more about buy till you die, and I'm going to have a better understanding of the buy till you die models. Right now, I don't really understand them as well as I need to, and I very deliberately talked about them today because one of the things I wanted to convey is, beneath the surface, how messy this stuff looks. By the end, hopefully, we're going to be in a position to, present our results with confidence and explain what we did and why we did it and how we did it, and kind of ignore all the chaos that happened before. But from a practical point of view, this is the kind of stuff that people don't really talk about enough, I think, because it's a very real part of this process. And while obviously from a stakeholder point of view, you don't really want to go down that road. From a practical point of view of actually doing this stuff in practice, they're always as messy as this. It's very, very rare where from start to finish where you're going to go with it. So I kind of wanted to capture that, and hopefully I did today. Thank you very much. We will be back next month. I'm conscious it's towards the end of April here. I probably won't quit quite so long and quite so late in the month. Just on the off chance, it'll probably be maybe Monday the 17th. I'm going to target now. Well, that's only 3 weeks ago. Maybe it'll be the 24th. Yeah, give myself 4 weeks. I would like to, be able to talk about buy till you die with a bit more confidence for the next one. But yeah, so there's a bunch of things we're going to do on the association rules. There's a bunch of things to be done on buy till you die. I'm also probably going to make a call on exactly what this project is going to output. And that will be dictated by basically how the next couple of weeks go. My gut feeling, it will be a combination of this and buy till you die. I'm not sure how useful, as much as I like it, I'm not sure how useful time series will be for this. But I'm going to leave it there. I'm going to hang around. For a few minutes. If anyone has any questions, I see your comment, Sylvia. Yeah, absolutely no problem. Let me just kind of clear all this away first and let people have any questions. And then once we're done with all that, I'll happily have a chat with you about the visualization. But other than that, thank you very much. I'm actually going to stop the recording now so that if anyone has any questions that they'd rather ask me off screen, they can do. And I will turn off the video. Well, let me stop the recording. But yeah, hopefully we'll see you next month.